AC minus BD equals N times this multiple, now we can translate this into AC is what, BD? Congruent to BD plus mod what? N. Do we care about this, what this is? No, that multiple doesn't make any difference as long as it's times N. So this you have to write an explanation, definition of congruence modulo. There we go. That's it. Huh? Oh, that's right. There's no plus in there. Thank you. That's right. It's AC is congruent to BD mod N. Yeah. That's that. Let's go to the next level and do an equivalence class of this modular math. If you can do this, everything for the quiz is going to make sense. So we're going to start off with XRY is going to imply X congruent to Y mod N. That's what we're given. Okay? And we want to show that it's equivalence. But this is what the relation is. I can get rid of this. Okay. And by the way, what is the equation for this one? Yep. The equation for this one is X minus Y equals N times T, where T is the element of the integers. I'll get rid of that fish. Bye, fish. I'm going to take this out, too. Okay? All right, next. If you have reflexive, what is that? What kind of a relation is reflexive? X related to what? X. So that should be, if you went X minus X, what's X minus X? 0. And what value for T would make this true? What's that? 0. So we would say where T is equal to 0, and 0 is an element of the integers, isn't it? So this is true, isn't it? So therefore, now we have XRX is equal to X congruent to X mod N. We've just showed that that's true. And then you have to write, therefore, R is what? Reflexive, yeah. Good. Let's do the next one. What do you start with? Yep. So we're going to start with, we've got X, R, Y, and we're going to just start with that again. X, R, Y implies X is congruent to Y mod N, or X minus Y equals N times T, where T is the element of the integers. Can I multiply both sides by -1? Is that legal? Yep. And then on this side, I'm going to get negative X plus Y equals N times negative T. What could we do with this thing? Switch it, Y minus X equals N times negative T. Can we say where T is an element of the integers? Or I'd say negative T is an element of the integers. Is the opposite of T an element of the integers? Yeah. It would have to be, because integers are positive and negative. The positive ones would be integers as the negatives would be. I'm doing an algebraic manipulation of this, which I know is true. It's like multiplying both sides by 2.
That makes it y minus x.
Then I can do the algebra to see this is the opposite of negative y, opposite of x. And then this one, what I'm really getting at is this opposite of t is still an integer. So then what we can say here is y minus x equals n times t, which can go to what? What can we then say? Y is congruent to x mod n. What's that? Yep, therefore R is symmetric. What do you guys think? Can you do these? This is doable, isn't it? It just seems a little clunky. We're proving that this x congruent to y mod n is congruent to y congruent to x mod n. That's symmetric. I want to get the, oh, you know what? I like your thinking. Let's write one more thing, y r x. Then that was our goal. That's what we were proving. We're proving that x r y is the same thing as y r x. Therefore, you could, and show that it's equal to this. Love it. Ready to do the last one? Okay, the last one. Try it. See how far you get. You try it. Just too much on the board here. How about this? So there's the reflexive, there's the symmetric, and now I'm going to do the transitive. Last one, transitive. Well, what we know is x, r, y, and what? Y, r, x should give me eventually what? X, R, Z. There you go. Nice. So we can write these equations. X, R, Y, we already know is x is congruent to y mod n. And we know that this is y is, this should be a Z. Y is congruent y is congruent to z mod n. Okay, then the equation that you have is x minus y equals n times t, where t is an element of what? Integers, yep. And then y minus z is equal to n times l, where L is the element of the integers. Now what do you want to do? We've kind of done this already, haven't we? We're going to solve for x, n t plus y, and we're going to solve for negative z, which is nl minus y. Why did I do minus z? So I can get x minus z. So here it goes. X minus z, it's like adding these together. It's going to be nt plus y plus nl minus y. What happens to the y's? They're out of there. So you have x minus z is equal to n times t plus l. I group those together, where n plus l is an element of the what? If each one of those are integers, you add them together, that's also going to be an element of the integers. So now can we say? X is congruent to Z mod N, and this is the definition of congruence. It's just starting to flow a little bit. Modulu. I'd like to say it that way. And therefore, do we have XRZ? Yeah. Now we're now. How many runners in here? What's the best part of the race? When it's over? Yeah. Sounds like it. Yeah. Sounds like me too. Therefore, since this is the victory lap, since R is reflexive, symmetric, and transitive, then R is an equivalent relation. How we doing? Real quick, this is for Jake. Number 5. This one's really cool because we did that a couple of problems ago, and this is pretty much the same thing. You start with A minus B equal to N times, let's go, I like that T. I stick with T for Tom. Where T is an element of the integers. My first name starts with T as well, so it's kind of inside. Now, what I'm going to do, Jake, is I'm going to solve for A this time. A is going to be B plus NT. And then I'm going to, once you get it into equation form, you can do whatever you do with equations. So we could add something, multiply to something. How about if we square both sides? No problem. You get A squared equal to B squared. That's what I want. 2bnt, not so much in favor of that, plus n squared t squared, not so much in favor of that. But I could take out a what out of these two? An n, and that's what I want. 2bt plus nt squared, where 2bt plus nt squared, element of the integers. And you could say, since b, l, n, t are integers, multiplying them and adding them would also have to be an integer. So then you're home free. A squared is congruent to b squared mod what? Yeah, that's the n. And that's the definition of congruent module.